Okay, welcome back to week 4. We're going to start this off by reviewing some more key terms, but we're going to do so in the context of the actual database management software. In this case, I'm going to use Libre. Again, Libre and Office and Access are very, very similar. The key advantage for me for this recording is actually the fact that the inner windows are kind of free to roam. I'll show you Access real quick. So inside of Access, these tables and stuff inside of the GUI, the user interface, I can't pull them out of the side of this window. So for someone like me that uses multiple screens, this is a little annoying. So Libre is actually winning my praise on this one. And we're not going to be using the programs this week, but we will next week. So please make sure that you have them downloaded and ready to go for when we start doing SQL. But until then, I'm going to just show you these just so you get a little bit more familiarity with them and connecting them mentally to what we've been doing before. So the key term, well, really quick. So this here is basically a computerized version of our ERD. How did I get here? You just go to Tools or Relationships. That brings this up. And then each of these tables show our actual data and database tables, and that's those 3 tables. Okay, so get rid of that, bring this here, bring up the key terms that are in the PowerPoint that you're actually looking at. Okay, so what is a relation? Okay, so remember in our ERD, these are the lines, or sorry, these are the entities, not relationship, but relation. These are the entities or tables. So here, starter, rel, stater, sport, and sport are tables, and you can see that in the table view in our database program, they are actually tables. Go figure. Tuple is a record or row or instance. So each of those rows didn't show up in our relationship diagram, right? But you do see them in the actual data. So you see here, sports, we have 1, 2, 3, 4, 5, 6, 7 different sports, which I could have known by just by doing that instead of trying to look how many there were. Each one has a unique ID. So we know that we've got like high jump, HIJ is the key that tells us that this is high jump. We have 33 records for the rel starter sport table and 20 records for our starter. Basically, these are our people doing these sports. Okay. So tuple, record, row, instance. I tend to use record and row, whereas like Dr. Labrie likes tuple a lot. He really loves that word. Attribute are fields or columns, right? So in here, you can see like sport. Sport has 2 attributes, and you can see that in our ERD, and you can see it reflected in our table, just as promised. Cardinality. So that is the maximum count of the number of records allowed in a relationship per key, right? So that's, is it maximum 1 or is it maximum many, basically? We don't have anything limiting the number of entries in here. So it's literally just 1 to many as you want. In Libre, this is shown as a little n right here. In Access, they use the infinity sign. So we have a little bit of variation between programs. But those are two different, very, very common ways you'll see them. Usually the crow's feet is something that you see in more hand-drawn type things rather than these programs, from what I understand. Right, so that's the maximum count of the number of records allowed in a relationship per key. Degree is the number of attributes in a relation or table, i.e. the number of columns. So sport, we only have 2 there. This one we only have 2. This one we have 5. Then a view is a peek into the table, basically. So when we talked earlier about like how the example I gave was that the managers and the HR folks at my company looking at the employee engagement survey, they were allowed to have different views. So the queries behind those views pulled up different information based on their user, like what they were allowed to have for those views, right? So if I manage 3 people, I can see their data. So the query that pulls up their data is different than the one that my boss would have, because they'd be able to see mine, theirs, everybody else at my level, and all their direct reports. And HR gets to see all because, you know, HR is omnipresent in companies. Not really. Okay, keys. So we have the candidate keys, which were the anything that is unique and could possibly be used as a primary key. We have the actual primary keys. You can see in the programs that they have a little tiny key next to them to show that, ooh, this one was selected. The foreign keys, which also have keys on them. So that's something to keep in mind, and you'd want to look at that to identify, is this a primary key for this table or is it a foreign key? So in this case, the naming convention that they had created was that here in starter, the primary key is just ID, but when they brought it over as a foreign key, they renamed it to show what table it came from. That is one common way of doing it. Switching back over to access. So here you can see product ID is brought over here, product ID. Same exact naming convention. Order ID is brought over here again to order ID. Same exact naming convention. So those naming conventions are personal preferences. I prefer the way that whoever did the access one did, where it's the same exact name, so it's very, very easy to identify. But it's your choice. Composite key. So you notice that this table here doesn't have its own unique ID sitting there. So when you see things like that, then they probably end up using this as a composite key where they're sticking them together to figure out which row they're talking about. Notice that this table here is actually an associative entity, because if you ignore that table in there, this is basically a many-to-many relationship, right? So we have a bunch of different starters here and all these different sports. You can look at the ID starter, and this doesn't have any useful information other than it's connecting these two tables together, right? So you look at the ID starter, and we have multiple ID zeros, right? So Carl starts in 4 different sports, right? Whereas Mia also has 4 different sports. Whereas Maria, different Mia, has 2 different sports, right? So you can see that LOJ is in several different relationships here. So you can see visually that, yes, this is a many-many relationship. It's allowed, and they've done that. Okay. And then I'm going to take another snippet of our PowerPoint and bring it over here into the same shared view. But you can look at your own PowerPoint for this. So what do we know about tables? This is a slide from week 2, I believe. So this is all, again, just review, just reminders. It's fundamental concepts. Each of our tables or relation or file, database has multiple. Each represents one object. So we have sport, we have the starters, and then we have the associative entity that was created by combining those two together in the money-many relationship. Rows and records, we see those. Columns, we see those. Table properties. So each table has a unique name. You can see that here. This is our starter table, sport table, rel starter sport. You can also tell by the awkward naming that it was definitely an associative entity and not a real just noun. None of our rows have duplicate values. So these main entities, they all have unique IDs, right? Here, even though we have the repeated foreign keys going on because of the many-to-many, each row is still unique. You don't have two entries that are exactly the same here. So each row is still unique. Cells have one value each. You see that. Each column contains only one type of data. We see that as well. Oh, it's just an example of a constraint. We'll get to that later. There we go. Don't click things. The last thing in here is that the order is insignificant. So here, they're pulled up in an order, usually by ID, an alphabetical order. But when we're doing a query, they can actually populate in any order whatsoever. So if I asked, if I did a SQL query on here asking something about how many women are starters in a particular sport, the results might not come back alphabetically. They could appear in any order whatsoever in the table I create from the query. So these orders, even though they look to us like they're in order, they're really, really not. They're just kind of coincidentally sitting there in alphabetical order just because that's the way it presented it to us, if that makes sense. Okay, so now that we kind of get a little bit better idea of what these concepts look like that we already know, what they look like in our database, I'm going to talk about constraints and do a little bit of a demo. Again, just to illustrate the ideas, you don't need to know how to do this stuff yourself quite yet.